It's comparable to AIM competition. This is a competition, I don't know what it stands for, but in 1988, this is very, very similar. We're supposed to compute the probability that a randomly selected positive divisor of 15 to the 49 is an integer multiple. Now, it's clear that we're talking about integers here, so I think integers sort of superfluous here, but in any event, we're supposed to find the probability. And so that's a tantamount to just counting all of these guys, putting it in the denominator, then counting all of these and putting it in the numerator. It's the desirables over the total outcomes. Now, 15 is a nice number in the sense that it's 3 times 5. And so it's semi-prime. What happened here? I lost my marker, it looks like. Okay, so 15 is equal to 3 times 5. And that makes it fairly easy. I mean, it's easy to count no matter how many primes you have, but this kind of minimizes the computation here. So a positive divisor of 15 to the 49 has to definitely be in this form. Now notice we have to allow for the exponent of 0 here because, just for example, 3 to the 0 times 5 squared gives you a perfectly legitimate divisor. This is equal to 25, right? And you can tell by inspection that 25 would have to be a divisor of 15 to the 49 because, you know, 5 to the 49th would be a divisor. So 5 squared is certainly a divisor, right? Okay, so that's why we have to allow for 0 right here. So 0 through 49, 2 degrees of freedom right here, you have 50 times 50 divisors. Okay, 50 times 50. So that will be the denominator of our so-called sample space from a probability point of view, desirable outcomes. So 50 times 50 is the total number of positive divisors of this number 15 raised to the 49th power. Okay. Now we're talking about integer multiples of 15 to the 37. And so again, in a similar fashion, we write down the form that would have to be in. Again, it's in the form 3 to some exponent, 5 to some exponent. But here, for it to be a multiple, it has to be at least 37, right? It has to be, at least be 37. It could be 37 in both cases because any number is a multiple of itself is a way to look at that, right, folks? Okay, but notice right here, from 37 to 49 is actually 13 possibilities, right? If you think about it, from 1 to 2, there's 2 numbers there, but it's you have to add one more. So there's 13 possibilities here for our desirable outcome. 13 times 13. Okay, so our the probability here, the probability that we're looking for is actually 13 squared over 50 squared. A fairly nice problem, folks. I liked it. Again, you have to go all the way back to 1988, long, long time ago, when this was an actual problem. I just picked it different. It's the same kind of problem. I think they used 10 to the 99th or something. But anyway, that is our answer. As far as I know, folks, I don't think I made any mistakes. And it turned out to be a fairly simple combinatorics problem. Right, Saturn?